Rahim. Remark first one, if W is any other subspace of the vector space V over the field F containing the set S, that is if the set S is the set S consists of element v1, v2 up to so on vn, which is a subset of the subspace W, and which is a vector, which is the subspace of the vector space V over the field F. Then the linear span of the set S is a subset of the subspace W. That is each that is the set S have a finite elements v1 up to vn. Then the linear span of S has a finite element of the vector space V over the field F. But the set S is a subset of the subspace W over the field F. Therefore, the linear span S, the linear span of S is a subspace which is proved in our previous theorem. This will be a subspace, and this subspace will be a subspace of the subspace W of the vector space V over the field F. And the second remark, that if LS, linear span of S, is the smallest subspace of V over the field F containing S, and is called subspace spanned by the span generated by the set S. And the second remark, that is if the set S is a subset of the vector space V over the field S, then each element Vi of the set S is containing in the linear span of S. Therefore, and the linear span of S is a subspace of the vector space V over the field F, and this linear span of the vector of the set S over the field F is the smallest subspan contained in the vector space V over the field F. That is the element, that is each element of this set S is contained in the linear span of S. For example, we select one of the element V1. V1 can be written as a linear combination of the element of S, that is 1 multiplied by V1 plus 0 multiplied by V2 plus 0 multiplied by V3 up to so on 0 multiplied by Vn, that is such that the element 1 and 0 are the element of the field which gives the element V1. This element is an element of the linear span of S, and so on for V2, 0 multiplied by V1 plus 1 multiplied by V2, and so on. The result is contained in the linear span of S. That is, each element of the set S is contained in the linear span of S. Therefore, the set S is, that is the set S is contained in the linear span of S. The linear span of S is a subspace of the vector space V over the field F. Therefore, the linear span of S containing the set S and is the smallest subspace of the vector space V over the field F span the linear span spanned by the set S, or generated by the set S.